Hi, good morning once again, class. Here we are again at top secret location number 2 in downtown Morgan, North Carolina. I've completed the service change here. I'll come back tomorrow morning early and do all that crawling under the house to change out that wiring from this panel to the panel that's under the house and convert that panel into a junction box. So I don't have time for that today. I've got to get to work, but just wanted you to see this is almost the same condition I left it in earlier, but you notice we've got our conductors in. I'm not going to open the box, but the conductors are connected up in the meter in the utility section of this. If you notice here where it says emergency disconnect, that's so the fire department knows that there's a main breaker in there, and if they cut that off, it cuts off all the power inside that structure. Okay, that's becoming more and more a prominent rule. Some places, I did some work in Louisiana, well, it's been a while, but even back then, because you know they're hurricane prone, one thing and another, and their fire code down there, you have to put a switch out here. I mean, a main breaker like this will not suffice. You have to put a meter base, and you have to actually pull a pull handle, a safety switch on the outside of every structure in Slidell, Louisiana, where I was. That's required. So that all the fire department guy has to do is walk up and pull that handle down. He don't even have to try and figure out how to open that thing up. He just reach up there, pull that handle, and all the power in the structure's off. It's not a bad rule, to be honest, but I expect one day we'll see it here. That may bypass my time, but we'll see. And just so you know, a safety switch is, you know, we've got one in our electrical lab over there next, around the corner from the sink, that big old switch with a handle. That's a safety switch. Okay, so what have I done here? I did get the conductor, excuse me, that's 4-aught aluminum, ungrounded, with a 2-aught aluminum neutral feeding down. And I found out, and this interesting, I'm not taking it out, there's no reason to, but see there where it says remote disconnect? You know what that means? That means that this meter allows the city to cut the power off to the structure from their office, which they've done. Now it's uninhabited now, and the owner, I don't know if the man that I'm working for just bought it or what, but he's remodeling, but there's no power on in there. I didn't realize that, or I wouldn't have bothered to do all that, because the city has that meter shut off. So until somebody goes and pays a deposit and gets the power turned on, they won't turn it back on, and I wouldn't have had to bother with all that. But there's no point taking it out at this point. When I come back to do the wiring under the house, since I'm going to have to open it up anyway, I'll do away with it. But what did we do? We drove an 8-foot ground rod here, and up here about 7 feet away we drove another 8-foot ground rod. Notice I left a hole dug around them, and these are driven below the surface of the ground. That way, once they're covered up, there's 8 feet of rod in contact with the earth, and that's in compliance with the NEC. You can get by without doing that, but you know, you have to move them out off the house a little ways so you clear the foundation, and so that kind of puts them in the yard. And you leave them sticking up, and they're a hazard. And I don't do that. I drive them out of the way. But I want you to notice something here. We've got 2 types of wire, and this is something you can do. You don't actually have to, but you can do this. That's number 6 solid wire that's coming down and going to that rod, and you can't really see it because it's under the earth, but there's another clamp, and that's number 4 stranded that's coming out of that rod and going up here and connecting to that ground rod. Why'd you do that, you ask? Well, I didn't have a piece of number 6 solid long enough to make the distance from there to there to there. The code requires that from here to here, that must be a solid piece of wire. It cannot be spliced in any way, shape, or form. From here to here, it cannot be spliced in any way, shape, or form. However, you can use 2 clamps and use 2 separate pieces of wire to make that connection. Since there's a connection at the clamp anyway, the code allows for that. The most interesting thing I want you to see is, though, of course, this is bare copper, and bare copper can be buried directly in the earth without issue. Obviously, I mean, it's an earth element, but it can be buried directly in the earth. But this number 4 copper wasn't originally stranded. I mean, originally bare. it was insulated with green insulation. Pick that up out of the man jar and leave no trash behind if we can help it. But I took all the insulation off from here to here. Why did I do that? I mean, let's think about it. Green, there's a green wire. Green is the color of a grounding conductor. And it would be perfectly legal to run a green insulated wire down to this ground rod. But the problem you run into with some inspectors, and I'm not going to say that the Morganton inspector would do this or wouldn't. I've had this happen before, and so I learned to avoid making the mistake in the event that that's how he interprets the code. There is leeway in code interpretation, and the inspector always has the upper hand. You just need to learn that from the get-go. I mean, you can press a case if you're right, and most of them are reasonable, and if you're not, difficult, they'll reason with you. It's not a big deal. But at the end of the day, the call is his. So the problem with leaving it insulated is that although copper is perfectly okay to be buried directly in the earth, the insulation that was on that wire did not have a direct burial rating on it. Now, you and me both know that's kind of asinine. The copper is what matters, and the copper is rated. But in the past, I did have an inspector turn me down because I used some green wire, it just happened to be what I had, and I didn't skin it from where it went into the ground to the rod and buried it. And he said that insulation was not rated for direct burial, therefore it couldn't be buried. And I had to go back out there and skin a foot of wire to pass that inspection. That's a little petty, but that kind of thing does happen. So you live and you learn. So when you're going to use the insulated stuff again, because that happened to be what I had, copper's quite expensive and I have an extensive scrap pile. It's perfectly legal to use solid copper number 6. It's perfectly legal to use stranded copper number 6 or number 4. 4 is a size bigger. Bigger ain't, that's not a problem. If I went down to an 8, he would turn it down. So that's all fine, but you live and you learn, and you scrape off the insulation or you skin off the insulation and you move on, because if you don't, you may be coming back. Okay, so that's where we stand, and tomorrow, good Lord willing, we'll complete this. Y'all have a great day. Bye. Good morning, class. We have returned to top secret location number 2 in downtown Morganton. Gonna wrap this little service change and partial, it's not really a rewire, it's just a service change job up. And what I'm doing, the service is mounted on the outside, you know this. What I have done, if you can see it, that panel to the left of the block column there, it's now been gutted. That's an old fuse panel. There's nothing left in it but the wiring coming into it from the different circuits in the home. I'm going to turn that into a junction box. Okay, and that girder beam down the middle there goes all the way from end to end of the house. What I'm going to be doing, as you notice here, this is 6 12-2 Romex cables, 30 foot in length. I pre-measured the wire that I would need, and I've just taped them together at intervals. And my plan is to go up here and feed that in through up here in the panel. Won't have any power to worry about here. So that opening right there, you can see the old cable. I will yank that out, but I'll push that Romex in there and we will just simply pull it the length of the house. So why'd you tape all that together, you say? Well, you learn over the years, if you don't use your head for something besides a hat rack in this business, you'll chase your tail a lot. You're going to do a lot of extra work. By taping these wires together, I have 7 circuits down there that I need to tie in. I can make 1 trip across the bottom of that. Well, actually it'll be 2 trips. I'll have to crawl over there to get it and pull it over to my panel, or my junction box, excuse me, work it into my junction, then go back across the beam and support this Romex every 4.5 feet. Now, if I have some straps or clamps or something large enough to support that bundle, I'll just do that every 4.5 feet since it's taped together. If not, I'll just have to, use Romex staples and staple 2 or 3 together at each place every 4.5 feet and support it into the box. And so the idea here is to keep me from having to make, you know, 15 trips back and forth across in that crawl space. I hope to reduce it to 2 or 3 trips and get all my work done. So I'll bring you back when we get a little further along. All right, class, here we are under the house. Isn't it lovely? Huh? If you're an electrician and you do residential work, you will get familiar with these surroundings. Not that big a deal. Anyway, just wanted to show you this. I've completed this junction box, removed all the innards from it except the neutral bus, which I left in place so I could ground it. You see, I've got a ground and a bonding jumper there. And the way I have you make those wire joints up in class, that's how I make them up in the field. You notice, keep the wire as long as I can. You never know when you're going to need more wire. That is 6 circuits that have been pulled in, supported here within a foot of the box, every 4.5 feet, all the way back down to where it's going to go out and make up in the panel. So what am I going to do now? Well, this is done. I'm going to put a cover on it, and what I have had to do here, you notice I've put a screw that used to be a fuse panel. We've converted it to a junction box, so we marked it so, put this on it. I don't know if that's really code necessary, but looks good. Inspectors like it, so whatever. But I have put a screw in that door so that door cannot be opened. You must unscrew it. So what will we do here is we'll just simply hang our box, and we'll put the mounting screw on the bottom here and close it up, and that'll be that. That one wire hanging there is for the furnace. I got to pull one more wire out of the panel to the furnace, put a switch right there and hook that up, and then go outside and make up the panel, and this job will be done. Okay, just wanted you to see this phase of it, and bring you back when we finish it.